Hello everyone, my topic is temperature and pressure distribution, both horizontal and vertical. Presented by Ms.G DHARSHINI, Assistant Professor of Geology, A.D.M.COLLEGE for Women, Nagapattinam. Okay, this presentation provides a comprehensive overview of vertical and horizontal distribution of atmospheric temperature and atmospheric pressure. We will explore the key factors influencing these patterns and their crucial role in the shaping global weather and climate. Okay, what we can see is introduction and atmospheric temperature, what is insulation, what is isotherm, and vertical distribution of temperature and horizontal distribution of temperature, and what is the atmospheric pressure, isobars, and the horizontal and vertical distribution of atmospheric pressure. Conclusion. Okay, introduction. This presentation will explore the fundamental principles governing atmospheric temperature and pressure. We will define these four meteorological elements and examine their distribution both vertically through the atmosphere and horizontally across the globe. Understanding the intricate relationship between the temperature and pressure is crucial, as their variations are the primary drivers of weather phenomena, long-term climate patterns, and the conditions necessary for life on our planet. Okay, atmospheric temperature. What is atmospheric temperature? Atmospheric temperature is a measure of heat at different levels of the air atmosphere, governed by factors like incoming solar radiation, humidity, altitude, etc. Okay, near the surface, air temperature is measured using the standard methods defined by World Meteorological Organizations like the WMO to ensure global consistency. And insulation. Heating of the atmosphere is insulation. So insulation is the incoming solar radiation received by the Earth's surface. The Earth's surface absorbs these radiations, which then heats the atmosphere. The angle of sun rays significantly impact the concentration of energy. Longer day-night hours result in greater amounts of insulation received. The greenhouse effect traps heat, warming the planet's lower temperature. So their energy budget balance the incoming solar radiations with the outgoing thermal radiation. Okay, isotherms. Isotherms are defined as lines on the map connecting points that have equal temperatures. The term is derived from the two words, iso and therm. Okay, iso means equal and therm means temperature. These lines are primarily used to illustrate the horizontal distribution of temperature across the latitudes over the surface of the Earth. Closely spaced isotherms significantly a high temperature difference over a short distance. Okay, widely spaced isotherms indicate more gradual temperature change. These pictures show isotherms in January and isotherms in July in global warming. Vertical distribution of temperature. Okay, the temperature decreases with the altitude in the troposphere. In normal gravity state, the temperature normal gravity state, what is the normal state? The temperature decreases with the height at an average rate of 6.5 degrees Celsius per kilometer. So this is called a normal gravity state. Okay, the troposphere is the lowest layer where the most weather phenomena occur. For that, warmest air is at low term, heated by the Earth's surface. there is a greater vertical movement of heat and water vapor. This turbulence is the primary reason all weather occurs within the troposphere. In the stratosphere, temperature increases due to ultraviolet radiation absorption by ozone. This absorption causes heat this air layer from the top down. The mesosphere experiences a decrease in temperature with increasing altitude. Domination solar radiation as most has been observed by the layers below it. The temperature rises dramatically in the thermosphere due to the solar radiation absorption. The absorption of strong insulating radiation from the sun, particularly at the level of Van Allen radiation belts. Okay, each atmospheric layer is separated by a boundary known as a pass. Temperature inversion. The temperature inversion is a layer in the atmosphere where the air temperature increases with the height. Okay, these create a stable air mass where cooler, denser air is trapped near the surface of the layer of warmer, less dense air is above. The formation condition, how it is formed. Okay. Clear skies and calm sea. Okay, the ground radiates heat and cools rapidly at night without cloud cover to the trap heat or wind to mix the air. The impact, what are the impacts of inversion? Okay, because the warm air naturally rises, the cooler air under an inversion is trapped. So during an inversion, and this vertical mixing is blocked. So this acts like a lid concentrating smokes, pollutants and allergens near the ground, leading to poor air quality and visibility issues. Okay. Understanding the temperature inversions in normal condition and temperature inversion conditions. Factors affecting the horizontal distribution of temperature. Okay, beyond altitude, the temperature varies significantly across the globe. This horizontal distribution is driven by a complex interplay of factors creating the diverse climates we experience from the equator to the poles. The temperature at any given point on Earth not be a result of a single factor but the dynamic interaction of multiple systems. Okay, latitude, altitude, distribution of land and water and ocean currents, prevailing winds, these are the factors. Okay, first, latitude. Insolation intensity varies with latitude, decreasing towards the poles. Altitude. Temperature generally decreases with an increasing in elevation. And distribution of land and water. Land heats and cools more rapidly than the water. Okay, ocean currents. Warm and cold currents redistribute thermal energy globally. Prevailing winds. Winds transport heat from one region to another region. Okay, this picture shows the horizontal distribution of temperature. Okay, as we can see is atmospheric pressure. Atmospheric pressure is defined as the force exerted by the weight of air molecules above the Earth's surface per unit area. Okay, due to gravity, the column of an air within a cross-section area of 1 square centimeter from the sea level to the top of the atmosphere has mass of about 1.03 kilograms, okay, exerting a force of 10.1 newtons. The average atmospheric pressure at sea level is a standard measure. Okay. 1013.25 millibars, which is also defined as the 1 standard atmosphere, okay, or 14.7 pounds per square inch. PSI is called PSI. Okay, the primary instrument for measuring atmospheric pressure is the barometer. The temperature is a primary driver of air pressure. Atmospheric pressure and temperature are inversely related. Okay, with an increase in temperature, the air expands and the number of molecules per unit area decreases, which leads to the decrease in pressure. So when the temperature falls, the air contracts and the pressure is increases. Vertical distribution of atmospheric pressure. The atmospheric pressure systematically decreases with an increasing in altitude. These occur because at higher elevations there is a less overlying air mass weighting down from the above. Air is highly compressible, meaning it is the densest at the surface due to the weight of air above it. Consequently, the pressure drop is most significant at lower altitudes and becomes more gradual as one ages. This relationship is not linear. Instead, the pressure decreases correspondingly with height. The fundamental concept is meteorology. The vertical pressure gradient is much stronger than the horizontal one, but is balanced by the force of gravity, preventing strong upward winds, etc. The rate of decrease is approximately 1 mph for every 10 meter increase in elevations at a lower altitudes. Okay, this pressure shows the vertical distribution of pressure. Horizontal distribution of atmospheric pressure. The pressure also varies horizontally across the earth's surface. This variation is the primary case of motion or wind, which moves from high pressure areas to low pressure areas. The horizontal distribution of atmospheric pressure is fundamentally driven by a differential heating of Earth's surface. The warmer air expands, become less dense, and exert the lower pressure and forming a lower pressure system. Conversely, colder, denser air subsides, creating a high pressure system. This pressure difference over a distance creates a pressure gradient, which is the primary force driving a wind. Air actually flows from the areas of high pressure to the areas of low pressure. Okay. What is isobars? Horizontal distribution is visualized on map using isobars, imaginary lines that connect a point of equal atmospheric pressure. Okay, closely spaced isobars indicate a steep pressure gradient and result in strong winds. The widely spaced isobars indicate a gentle pressure gradient and result in light winds. Okay, the three keys of pressure variation. The three key drives of pressure variation. The first one is temperature, and second one is earth rotation, and third one is the water vapor. Okay, temperature. The thermal factors. There is an inversible relationship between the temperature and pressure. Hot air expands, become less dense and rises, creating a lower pressure at the surface. Cold air contracts, become denser and sinks and creating the higher pressure. Earth rotation. The rotation of the earth creates a forces like a Coriolis effect, okay, that cause a large scale air movements to coverage or diverge. It's a spread apart. So okay, these dynamically create areas of high and low pressure independent of temperature. Then third one is water vapor. So the amount of water vapor affect the air density. So moist air is less dense than the dry air because of what molecules? H2, okay, or lighter than the primary components of air, N2 and O2. Okay. Therefore, a higher concentration of water vapor leads to lower atmospheric pressure. Okay. Global pressure zones. The interplay of thermal and dynamic factors results in 7 major and semi-permanent pressure belts, but that circle and go. These belts are not static. Okay, they shift north and south, but apparent movement of sun through the air. First one is equatorial law. Cause thermally induced by intense of solar heating at the equator causes air warm, expand and causes air to rise. Okay, it is located in 0° latitude north to 5° latitude in north and south also. Characteristics: a zone of low pressure with a calm wind, the doldrums, where the trade winds are coverage, forming the intertropical coverance zones. It's called ITCS. Okay, second belt is subtropical heights, 30° to 35° latitude north and south. Cause dynamically induced. Okay, the air that rise at the equator poles moves poleward and sink back to the surface here. Okay, characteristic: sinking and dry air creates high pressure, clear skies and little rainfall. This zone is where many of the world's major deserts are located. The subpolar loss. Subpolar lows. Okay, 60° latitude to 65° latitude north and south. So located. Okay, cause dynamically induced formed at the polar front, where warm westerlies collide with the cold polar east, forcing the less dense warm air to rise. So what are the characteristics? A zone of convergence and rising air that leads to stormy weather and significant cyclonic activity. Okay, the final one is polar heights. It's located in 85° latitude to 90° latitude, north and south regions. So cause, what are the causes? Thermally induced is intense and persistent cold at the poles makes the air very dense and causing it to sink. Characteristics is in the cap of very cold and dry and high pressure are settled over each pole. Okay, the interplay global atmospheric circulation. The three cells are occurred. The first cell is Conley cell, and the second one is spiral cell, and third one is polar cell. The role of Earth rotation. There is what is a Coriolis effect. The Coriolis effect and upward force from the Earth rotation deflect wind to the right in the northern hemisphere and the left in the southern. Air initially moved by the pressure gradient force, high to low pressure. Okay, they are stand by the Coriolis effect. When these two forces balance, geotropic wind results. The flowing parallel to isobars and for curved isobars. This balance creates gradient winds, which govern the rotational flow of air around the high and low pressure systems. Okay, the summary of atmospheric pressure. The atmospheric pressure is the physical weight of an air above as a direct consequences of gravity acting on the atmosphere. This pressure decreases predictably with altitude, but it's a horizontal variation driven by a temperature, rotation, and moisture is what creates the weather. Okay, these horizontal variation organized into the global system of 7 distinct pressure belts formed by either thermal or dynamic processes. The constant movement of air between these high and low pressure belts is the engine that drives our planet resistant wind system and shape the large scale weather patterns. Conclusion. The temperature and pressure exhibit the distinct vertical and horizontal distribution patterns globally. The vertical temperature profiles define atmospheric layers. Pressure decreases exponentially with the altitude. Horizontal distribution is governed by the factors like latitude, long sea contract, and current. The temperature differences create pressure gradients, which are the fundamental drivers of wind. The interplay of these factors create the global pressure belts and circulation cells. The understanding these atmospheric dynamics is fundamental for meteorology and the climatic science. Thank you.